For centuries, skywatchers wondered what these unusually fuzzy-looking stars were.
People who looked at these things a long time ago from Earth thought they were just individual stars, and it really took the advent of modern telescopes to be able to tell that it was actually a group of stars.
These groups of stars are now known as globular clusters. Astronomers believe they were among the very first collections of stars to form in the universe. So studying them is like doing an archaeological dig, finding out what these early homesteaders of the galaxy look like and how they changed over time.
All of the stars in the cluster are orbiting around the center of the cluster, kind of like bees buzzing around a beehive. If they weren't moving, then they would all fall into the center. Just like if the Earth weren't moving around the sun, it would fall into the sun. And so the same thing would happen with stars in a cluster.
Knowing how the stars move will help scientists understand what's going on deep inside these stellar islands. But seeing the details of these beehive swarms wasn't easy to do until Hubble came along.
Its resolution is a lot better than you can get from normal telescopes from the ground. So you can separate two stars that are very, very close to each other with the Hubble, which from the ground just look like one blob.
You need a telescope which is very, very stable. What you're doing is you're doing a measurement and you're doing another measurement a few years later, and you try to see what changed. The reason it's much easier with Hubble is that Hubble is above the Earth's atmosphere. It's in a weightless environment. There is no seasons, there is no weather, there are no seismic events, and basically no one touches the telescope for years on end.
So with Hubble at the ready, astronomers looked at one of the biggest globular clusters orbiting our galaxy.
We began this project because there had been previous evidence for a massive black hole at the center of Omega Centauri, and we knew that HST had already taken images in 2002 and 2006 that should allow us to measure the motions of the stars at the center.
We feel that with the new measurements that we've done, the case for such a black hole is weaker than it was before. And we also think that if there is a black hole in the center of the cluster, it cannot be as massive as had been previously suggested.
This is one of the new UVIS images. If you just start with the images that we analyzed and look at one image and you compare it to another, just by eye you couldn't tell that the stars had moved. But if you use high-precision computer programs, you can analyze what their positions are in the two different time frames. Pretty much double the baseline that we had before. This allows us to sort of use the computers to tell us what the stars will look like 10 years from now, 15 years from now, 100 years from now.
It's studies like these scientists hope will give us insight into how our universe evolved. From the Space Telescope Science Institute in Baltimore, Maryland, I'm Mary Estacion.